That's my divergent harmonic. But you could say because P equals 1, that's fine. Alright, so now I want to know, by making pretty much half of them negative, is this going to give me a finite number? If we take the absolute value of it and it diverges, then we're going to use the alternating series test. Whoops.
If it's diverged?
If the absolute value of it diverges. Okay? The alternating series test has two parts to it. Alright, so this is for, so if we have the summation of -1 to the n of a sub n, or -1 to the n plus 1 a sub n. And we've got two steps, two things. First thing, we're going to look at the limit as n goes to infinity of a sub n. So notice the way these are written. When I'm looking at the limit as n goes to infinity of a sub n, am I taking account the sign? No, it's just saying I'm taking away the -1 to the n, and I'm looking at the other term. If the limit as n goes to infinity of a sub n has to equal to 0. It's got to equal to 0, and then the next thing is my n plus 1 term has to be less than my nth term. So this pretty much means my function is doing what? Decreasing. If these two things hold, then my series converges. So let's look at this one right here. And then I'll tell you how we say it. So let's look at here. So what's my limit as n goes to infinity? So step 1, what's my limit as n goes to infinity of 1 over n? 0. So when I look at the n plus 1 term compared to the nth term, that gives me n is less than n plus 1. 0 is less than 1. When is 0 less than 1?
Always.
Always. What's another thing I could have used right here? Derivative. And the derivative would have to be less than 0. So this is true, this is true. So this series is going to converge. The alternating series converges. Now, when we have it, when we say, okay, refocus. When the absolute value of a series diverges, but it converges by the alternating series test, we say that it converges conditionally. It still converges, we're just being more precise. We're just saying that it's got to alternate signs here for me to converge. On your homework, you're going to be asked, does it converge conditionally? Absolutely. I think on your test, I just think we say, does it converge or diverge?